Hi, this is Ms. McCahan, and we're going to review how to write the equation of a line. So in this example, we're going to write the equation of the line that passes through this point and has this slope. So because I am given a point and a slope, I'm going to use the point-slope form. And so as a reminder from Algebra 1, this is what that point-slope form looks like. Y equals m, x minus h plus k. And remember that m is still your slope, that's all that letter means. H is the x coordinate of your point, and k is the y coordinate of your point. So in this example up here, -3 is going to be my h, 4 is going to be my k, and 2/3 is my slope, that's the m. So when I plug those values into my formula, it's going to look like this. Y equals 2/3, that's where the slope is, that's where m is, x minus h, so look at it has x minus -3, and then plus 4, that's the y coordinate, the k. And I don't typically like to leave a minus and negative in my equation, so I'm going to rewrite that as 2/3 x plus 3. Remember, minus and negative is the same as plus a positive. And then I just brought down them plus 4. So now I'm going to rewrite this in slope-intercept form so that in case I wanted to graph it later, I could very easily. So I'm going to do 2/3 times x and 2/3 times 3. So when I distribute, I do 2/3 times x, that's just 2/3 x, and then 2/3 times 3, that gives me 2, and then I just brought down my plus 4 because that did not get distributed, that was not in parentheses. So my last step is I'm going to combine the like terms, the 2 plus the 4, and that's going to give me 6. So my final answer is y equals 2/3 x plus 6. Now notice I put 2/3 in parentheses. That's just so we know that the whole fraction 2/3 is in front of the x. Next I'm going to write the equation of the line that passes through a point again, but notice that the directions say it's parallel to this line. So remember that parallel lines have the same slope. We talked about that in the slope video. So the slope that we're going to be using for our line is just going to be the same as this one, 2. Notice here's my m, that's the slope 2. So our slope is going to be 2. So I'm going to use that same point slope formula and plug in my pieces. So I have 2 for my slope, and then I have my h and the k. Just to remind you, I'm getting those from my point. So this is my h, this is my k, and I have x minus h plus k. And again, I'm going to distribute my 2, my slope. So 2 times x and 2 times -2. So when I distribute, I'm going to get 2x minus 4, and then I'm just bringing down my plus -3. And again, I don't like to have double signs, so instead of saying plus -3, I just said -3. And then I need to combine these like terms, the -4 and the -3, and that gives me -7. So that's my final answer is y equals 2x minus 7. And this line would be parallel to this line. Now if I had said write a line that is perpendicular, so if I said I don't want parallel, if I want perpendicular, then I would do the same exact thing, except my lines would not have the same slope, they would have opposite reciprocals. Remember we talked about that before. So I wouldn't have a slope that was 2, I would have a slope that is -1/2. That's the opposite signs, and reciprocal, we flip that fraction around. So I would have a -1/2 right here, and I would do the same exact process. So now we're going to write the equations of both of these lines, and then we're going to see if they're parallel, perpendicular, maybe they're neither. And again, so remember from our slope video, we can find the slope of 2 points just by stacking them. And you could use the You could use the formula as well, but I just prefer to stack them. It's quicker for me. So if I just stack those points, I'm going to look at my y's. Remember, this is my x and this is my y. I can see that from -3 to 5, that's going up by 8. And then from over here, if I go from 3 down to 1, that's going down by 2. And then if I do my rise over run, that gives me a slope of -4. So 8 divided by -2 gives me -4. So now that I have my slope, I'm going to use my point slope form again. And we have two different points, so you can pick either one. I'm going to pick this one, the 1, 5, because it doesn't have a negative in it. So when I plug that in, I have my slope is -4, my h is 1, my k is 5, and that's what it looks like plugged in. And yes, again, we're going to distribute the -4. And when I do that, I get -4x. Remember, a -4 times a -1, that'll give me a +4, so I put +4 here, and then brought down my +5. And then I have to combine my like terms. So that's going to give me -4x plus 9. So that's the equation of line 1. Now let's go over here to line 2. Again, I stacked my points. And I'm going to see, okay, from 5 to 6, that went up 1. And then if I went from -4 to 0, that went up by 4. So if I do my rise over run, that's 1 over a +4. So my slope is simply 1/4. Okay, so once again, I have my slope, and I'm going to use one of these points. I'm going to pick this one. It doesn't have a negative in it. So if I plug that into my point slope form, I have 1/4 is my m, x minus h, here's my h, here's my k, and I'm going to distribute again. So I'm going to distribute the 1/4 to the x and to the 0. So I have 1/4 x minus 0. Remember, 1/4 times 0 is just 0. And then I just brought down my +6. So when I combine my 0 plus 6, that just gives me 6. So I have 1/4 x plus 6. Now, I don't know if you noticed this, but 0, 6 is in the format of a y-intercept. So you could have seen right away that this is a slope, this is a y-intercept, and you could just use y equals mx plus b, and you would get this form. Now, what I want to do is compare these lines. So if we look at these equations, I want you to notice their slopes. This has a slope of -4. This has a slope of 1/4. So we need to determine, are the lines for these sets of points, are they parallel, perpendicular, or neither? Well, what did we say? If I have opposite signs, so these have opposite signs, this one's positive, this one's negative, and then this is the reciprocal of 1/4. Remember, 4 is like over 1 secretly. We don't usually write over 1, but this is the reciprocal of that. It's the fraction flipped over. So that means that we have a perpendicular lines. If these were the same slopes, then we would have parallel lines. If they were not either of those, then we would say they're neither. They're not perpendicular or parallel.